Hi, in this video we'll talk about how to take a derivative of a logarithmic function. So what you need to know going into this is that the derivative of the natural log of x is simply equal to 1 over x. In more general terms, we can talk about the derivative of the natural log of u. And in that case, it's equal to 1 over u. I just take the u, stick it under a 1, just like over here. But then I have to take the derivative of u. And what it ends up being is the derivative of u over u. So let's apply that to a few examples. In number 48, we have f of x equals natural log of x minus 1, and I'm looking for the derivative of that. Okay, so again, I can use either one of these formulas. In this case, I can just stick the x minus 1 under 1, and then the derivative of x minus 1 is simply 1, so that is my final answer. Let's look at another one. All right, we know the natural log of x, the derivative of that is 1 over x, okay? But in this case, it's raised to a power, and now I'm going to have to use my power rule. I'll go down here. Recall that, this is good review, the derivative of u to the n, anything raised to the nth power, is n. I just take that power and stick it out front. Take u to the n minus 1, so take 1 off of n, and then I have to also take the derivative of u. We're going to use that over here for the natural log of x raised to the 4th. So let's forget that we're doing natural log for just a second and think about this as x to the 4th, or u to the 4th, I should say. It would become n, in this case it's 4. Take 1 off of there, so I have natural log of x raised to the 3rd. And then I have to take the derivative of u. In this case, my u is going to be natural log of x. Based on my formula over here, the natural log of x is just 1 over x. Okay? So my final answer in this case would be, let's see, 4 natural log x, all that cubed. Notice that the whole thing's getting cubed, not just the x. Okay? That's why I couldn't take this and simply stick it out front. All right? And all that would be over x. So that would be my answer. And now I have one more example for this video. Here I've got y equals x squared natural log of x. And now in this case, you can actually solve this one of two ways. We are actually, no, I was thinking the product rule, but the product rule is what we're going to use. Okay. And the product rule, again, means I take the first thing, derivative of the second, and add the second thing, derivative of the first. I like to remember this rule as 1d2 plus 2d1. And in this case, my u is going to be x squared, and my v is going to be natural log of x. So if we take the derivative of y, it's going to be u x squared, the derivative of v, in this case it's natural log of x, or 1 over x, and then to that I'm going to add v, which is just natural log of x, times the derivative of u, which is 2x. And from here I'm just going to do some simplification. X squared times 1 over x just leaves me an x, and over here I'm left with 2x natural log x. Notice that you can factor an x out, so in simplest terms I'm going to pull out an x and I'm left with 1 plus 2 natural log x. So those are 3 examples. In the next video I will give you 2 more, and in that video I will give you 1 or 2 ways to actually do those. Recall that we're bringing up some of our old rules here, the product rule in this case, and the power rule over here. Those rules have not gone away. The only thing new is that whenever we're taking the derivative of the natural log of x, it's simply 1 over x.